Hello everyone and welcome to the big video where we learn about convergence and divergence of a sequence. Now let's try to understand convergence and divergence intuitively through pictures. Let's try to draw a sequence, try to see some pictures, and let's try to understand this topic in that way. Hopefully it will help you to understand convergence and divergence better. This can be an intimidating thing to learn when you learn it for the very first time, but actually convergence and divergence of a sequence means a very simple thing. Now we classify a given sequence as convergent sequence or a divergent sequence based on the behavior of the given sequence. Okay, so it's kind of like a special property that every sequence has. So it's either can be a convergent sequence or a divergent sequence. Okay, so to learn about this, let's try to start from an example. Alright, I want you to forget about convergence and divergence word for a moment. Let's look at this simple example. Now here I have copied my Mathematica code into Microsoft OneNote, so in that way I can share some pictures with you. So my example sequence is 1 over n, okay? Look at the terms of this sequence. So I have typed out 10 terms of this sequence. If you look closely, they are decreasing, right? So first term is 1, the next term is 0.5, then the next term is 0.3, the other term is 0.25. So you can see the terms of the sequence are decreasing. Now if you look at the picture, that's what you see right away. It's a decreasing sequence, right? So that's something, that's a kind of property that this sequence has. But that doesn't mean it's convergent or divergent, okay? Forget about convergence and divergence for a moment. Here we are discussing about a decreasing sequence. Okay, even though the sequence is decreasing, it cannot decrease like crazily, right? I mean, think about this. I can say it like this. This sequence is not decreasing without a bound. Now, what do I mean? Now, think about this. The sequence is 1 over n, and remember, n is positive, right? N is the position. It cannot be a negative number. N is like 1, 2, 3, 4, 5, 6, 7, and so on. So 1 over n is definitely positive. Now you have only positive numbers and they are decreasing. They are getting smaller and smaller. So imagine these numbers cannot hope to be negative, right? So think about 0. So you have the number 0 here. Okay, so 0 is like a barrier for the sequence from below, under the sequence, right? Or you can think that 0 is telling to the sequence, you know what, I know that you are decreasing, but you dare not cross me, right? That's what going on. 0 is telling to the sequence, you cannot go beyond me, right? So 0 acts like what we can say a lower bound for this sequence, a lower barrier. Now this scenario is very interesting what's going on here. Now take a look at what happens to this sequence eventually. Okay, now when you keep on writing in terms of this sequence, or we call it that we are looking at the tail of the sequence, end of the sequence, okay, kind of the end of the sequence. Now they are getting really small and 0 is a lower barrier. Now you can see based on the numbers of the sequence, they are getting extremely close to 0, right? Imagine the terms that are extremely close to 0. They are jam-packed, right? That's what something interesting going on with this sequence, okay, at the end of the sequence. So we can say, because of this interesting behavior, we can say this sequence, or we say this sequence is convergent to 0. Eventually, terms of the sequence, terms of this particular sequence get closer, get really close to 0, get really close to a real number. Okay, right. Now there's another way you can understand convergence. Imagine something like this. Imagine that you are putting a tiny particle in the path of this sequence. What will happen to this particle? What is the path of this particle? Think that this particle is moving. Understand, this particle is going to get attracted by 0, right? Like 0 is like a magnet and this tiny particle is like a metal particle. This particle in this path will get attracted to 0, get really, really close to 0. Okay, so that's the kind of behavior that convergence sequences has. Okay, now when you talk about convergence and divergence, really we are looking at the sequence, we are looking what happens to the sequence eventually, or we are looking at the tail of the sequence. Okay, what happens to the sequence, what is happening to the sequence in the beginning, we do not care about that, because nothing interesting going on at the beginning in this sequence, right? But something interesting happens later in this sequence eventually. So convergence and divergence is talking about the eventual behavior of this sequence. All right, so let me take another example. Let's look at the sequence minus n square. Now minus n square, if you look at the terms of the sequence, they are also decreasing. Now can you say that they are decreasing with a bound? Like, is there a lower barrier? Let's look at the picture. Is there a barrier under the sequence? No, right? Think about this. The terms of the sequence are decreasing like crazy. See, negative 64, negative 81, negative 100. So they are, or in other words, think about this. If you put a particle here in the path of the sequence is moving in this direction. Don't look at what happens in the beginning of the sequence, okay? You're looking at what happens to the sequence later, eventually, okay? Right? So if you put a tiny particle on this path of the sequence, will it be attracted to a one real number? Where will it go? It will go to negative infinity, right? It will not go to a real number. By the way, infinity is not a real number. It's not a number, okay? Negative infinity, same. It's not a real number. So this particle doesn't get attracted, doesn't get close to a real number. There's nothing real, right? So in this case, this sequence doesn't approach to a real number, so we say this sequence is divergent. Okay, so in both these examples, both sequences were decreasing sequences, but there was a difference. The second example, it was decreasing without a bound. Okay, it was not attracted towards a one particular number eventually. Okay, but in the first sequence, yes, it's decreasing, but while it's decreasing, it's getting closer to a one real number. That's what called convergence. Okay, so convergence and divergence here. Now this doesn't only happen with decreasing sequences, so we have to look at examples of increasing and oscillating sequences as well, which we will do that in this video, but it's going to be really quick because now we know what convergence and divergence kind of is. Alright, here's my next example. The sequence 1 minus 1 over n. Now, if you look at the terms of the sequence, first term is 0, then 0.5, 0.6, 0.7. Now you can see the terms are increasing. But look at the picture. They are not like increasing crazily, right? They have a bound. If you look at this terms of the sequence, they kind of get flat later, right? Like the increasing rate is slowing down. Okay, now if you look at this sequence very carefully, okay, 1 minus 1 over n, 1 over n gets really small when n gets large, right? When you think about the tail of the sequence. Okay, so 1 over n gets really small means 1 over n is really close to 0. So 1 minus a tiny small number is a number really close to 1. Right? So the terms of this sequence, yes, they are increasing, but they are really getting closer to 1. Like 1 is like a barrier for the sequence from above. Right? So in previous example, we saw that 0 was a barrier for the sequence from below. Now 1 is a barrier for the sequence from above. It's again like if you put a particle on the path of the sequence, it will get attracted to 1. So again, this is a convergent sequence because this sequence is getting attracted to a real number because, of course, 1 is a real number. So this is a convergent sequence. So this is an example of an increasing sequence but convergent. Okay, very interesting. All right. So again, it's increasing with a certain limitation, increasing with a control. Now, in comparison to this example, sequence n square. Now n square again increasing 1, 4, 9, 16, 25, 36, so and so on. But this is increasing crazily. We say that this is increasing without a bound, without a control. Now if you put a tiny particle in the path of the sequence are moving in this direction, will it get attracted to a real number? No, it will go to infinity, but infinity is not a real number. So this is a divergent increasing sequence. Okay, so again the difference of convergence and divergence. Okay, one is, so you have to be attracted to a one real number, then that's where you get the convergence. Okay, so we saw 4 examples. 2 examples of increasing and a decreasing sequence where they are convergent, 2 examples of an increasing and decreasing sequence where they are divergent. Okay, now there's another type of sequence which we call oscillating sequences, where they neither increase or decrease. So let's look at that type of an example also. So my example for the oscillating sequence is -1 to the n over n. Now why do I say that this sequence is oscillating? Because if n is 1, let's try to write several terms of this sequence. When n is equal to 1, it's -1, right? If you substitute n is equal to 1. Now when n is equal to 2, it's going to be half. Okay, try it for yourself. When n is equal to 3, this is going to be -1/3, and when n is equal to 4, it's going to be 1/4. Now you can see the terms of the sequence, they are switching between positive and negative. Now if you try to plot this sequence, okay, so the first term of the sequence is like -1. Oops, that's not -1, it's like -1, and then when n is equal to 2, it's half. So it's here. So the terms of the sequence from here to here, it jumped, and then it will become -1/3. So that's like what here, right? So it's switching, it's oscillating, it's neither increasing or decreasing. This is not an increasing sequence or a decreasing sequence. Look at this picture. Now if you put a particle in the path of this sequence, does it get attracted to a one real number? If you put a particle here, you can see it seems to be like it's getting attracted to 0, right? No matter where you put the particle, it's getting attracted to 0. Even though you switch between signs in this sequence, if you take all the negative terms of this sequence, -1, -1/3, -1/5, they are increasing. That's what you see in this picture right here. These are all the negative terms of the sequence. They are increasing, but they can only increase up to 0, right? They will never get to 0, but they will get extremely close to 0. Right? All the positive terms of the sequence, they are like what? 1/2, 1/4, 1/6. So they are decreasing. So they are the terms that are displayed here. They are decreasing, but they can only decrease what? Up to this lower barrier, which is 0. So the positive terms, positive or negative, doesn't matter. Both of them get attracted to this one real number, which is 0. So hence again, this is a convergent sequence, even though it's neither increasing or decreasing. Okay, so this is an example of an oscillating sequence which is convergent. Look at the picture, look at the behavior, see how the terms of the sequence are approaching towards 0. That's what you call convergence. Okay, right, now at this moment I have to give you an example of an oscillating sequence which is divergent. So let's look at that. Here's the sequence, -1 to the n. Okay, now -1 to the n, if I write the terms of the sequence, it's -1, 1, -1, 1, -1, 1. So they're definitely switching between sign, but it's either 1 or it's either -1. Okay, now here's the thing. You might say, okay, wait a minute. If you put a particle here, see, it's always 1. Right? So it's approaching 1. It's approaching to a real number. It's already there. It doesn't even change. So you might say, hold on a second. This sequence is convergent to 1. So let's say this is student A who put a particle here. But let's say there comes another student. You know what? I'm going to put my particle here. and this particle will approach to what? -1. I mean, it's already there, nothing to approach, so it doesn't change. So you approach to 1 and -1. One particle approach to 1, other particle approach to -1. But you don't approach to a one single number, right? You approach to two different things. Now, when I said convergence before, I said you must approach to a one real number. I was carefully saying one real number, a unique real number. That's what I should have told, okay? So, since these particles approach to two different numbers, you cannot say that this sequence is convergent. This is a divergent sequence. Simply because they don't approach to a one single real number. If both of them have been approached to 1, fine, then convergent. But you are approaching to 1 and -1, two different numbers. So hence this is a divergent sequence. So really a divergent sequence means that either you're going to infinity, your particle is going to infinity, or -infinity, or goes to like couple different numbers, 2, 3, who knows, okay? If they doesn't approach to a one unique number, then again it's divergent, okay? So that's how you visualize convergence and divergence of a sequence. Hopefully I have taught you the intuitive idea of a convergent and divergent sequence through pictures, okay? In the next video, let's learn a method which is really a simple method which you have already learned, I'm sure, but a method where we can calculate with a method where we can decide the convergence and divergence by a mathematical way rather than looking at a picture. So let's learn that in the next video, because this video is all a little bit too long, because you know I like to talk too much. So I'll catch you in the next video. Thank you very much.